Today, July 9th, about 6:30. I'm back in the garage. Going to show you how I'm going to repair this loose pitman arm spindle hole here, where the spindle goes in. I've already drilled it out so that I can tap it with a 3/4 14 pipe tap. I'm going to plug it with that pipe plug you see right there. What I drilled it out with was this high-speed end mill. It was an old dull end mill I had laying around. I took it to work and spun it down to 937 thousandths, which is the tap drill size for the 3/4 10. So what I'm going to do, after I get that hole threaded, the tap, I'm going to tighten that pipe plug in there, and I'm going to go only so deep with the thread so I can tighten that plug in there good and tight, and then I'll just machine it all flat, and I will drill for the spindle to where it's a good press fit. I also have another cutter that I spun down for that. It's right here. I spun this down to, I believe it's 813 thousandths is the diameter of this, which is 13/16 is what it is. I didn't have a reamer for that. I didn't feel like buying one, so I took this old end mill and spun it down to that size. But anyway, after I get that pipe plug machined down, we'll go ahead and drill that hole and then ream it out with that little tool I made. And I'll show you what that looks like after I get done, and show you the other stuff I gotta do to get this mower back together. That's it for now. Okay, YouTube, I'm just back for a little bit here. I want to show you how I was going to go about getting that tapped hole in there tapped straight. Of course, you know, if you ever try to tap a hole, especially with a bigger size tap like this, it's really hard to get them started straight. So what I did, I stuck the end of my tap in the hole, and on the back side of the tap there's a center hole already in it, and I use this countersink as like a live center, and I just took my quill, which works like a drill press with the quill handle, and what I'm doing is I'm holding a little bit of pressure on there as I turn this tap, which I've already got it started. But just a little trick I wanted to show you about how I went about getting that tap straight in there. Okay, that's it for now. I'll show you more progress as we go along with this. Be right back. Okay, YouTube, I'm back again to continue this video. Just wanted to show you everything went good. The hole is plugged, and I re-drilled it to the right size. My cutter seemed to work out pretty good. You can take this pin, I'm going to have to drive it through the other side, but it feels like it's going to be a good snug fit. I'm going to have to tap it in from the other side. I'm going to take this piece off, clean it up, tap that in, then we'll come back and I'll show you how it fits, then show you what I got to do next to fix this thing. Okay, now we had the pin driven in. It's going to work pretty good. It was a little tight going in from about here to here when I drove it in this way, but this pin, from all that flopping around it did in that egg-shaped hole that was wore out, it is probably about 2 or 3 thousandths smaller from here down than it is up here. So I drove it about halfway through, and it was good, really tight. It took some effort to drive it in. Then after it went so far, it fell on through, and it was a little sloppy. It isn't now. What I did, most machinists probably wouldn't like this, but what can you do when you got a tapered pin? And I don't really want to make another one, and I think this is going to work good anyway. I peened around it. You can see where with a punch, which snugged it up good, and there's no slop in it at all now. And also what I'm going to do to help, something that should help stop this pin from being shoved back and forth and wallowing that hole out again, a spacer goes on the other side of your bearing like that, and then you've got this bearing that fits there like that, of course. And here is your pitman arm box, as they call it, which will go over there. That bearing goes in that race on this side, and then you got a race on the other side. So your bearings go in there like that. What I'm going to do, I'm going to make what they call a preload spacer in between those two bearings. When you get that spacer set just right, the right thickness, what it does is you can tighten this nut down really tight, and it won't let the preload of the bearings get too tight. It keeps those bearings in a certain set position. It sets your preload. Actually, it's kind of like a crush sleeve works on a Ford 9-inch is what it's similar to. That way, I can have this nut tightening down against all this. That's going to be pushed, that collar back there is going to be pushed up against there. And that is that much more space or more support for that spindle, keeping it from rocking back and forth. So that's what I plan on doing next. I got to do that. I got to make new arms to bolt to my pitman arm that I will weld on these. I'm not going to re-weld the old ones because they have been stressed all to hell from the beating they took, which is why they broke. I have some 3/16 steel, which is a little thicker than these. I'm going to make them out of. So that's where I'm at on that now. I think I'm going to go ahead and make those pieces first. Then we'll get to working on this bearing spacer here. And I'll get back with you and show you how that looks after I'm done with that. Okay, it's about 10 o'clock Saturday night. I'm in the middle of making these pieces for my pitman arm box. And I just want to show you a little bit part of the procedure of making them. I've already got my 4 holes located and drilled in, as you can see. Started out with a rectangular piece, squared it up, 3 sides. And in order to get that radius, I'm using a boring head in my mill, and I got an end mill instead of a boring bar. I like to use those because they don't flex as much, and you get a better cut. But as you can see, here's the piece it's going to fit on. It's a pretty close fit. What you do, you just adjust that boring bar. You turn this little the Allen wrench goes in there right there, and you just turn that and move this in and out until you get your right radius, the half circle that it cuts. Just thought I'd show a little bit of that. Thought somebody might find it interesting. But what I'm going to do is I'm going to move this in another 30 thousandths, taking 30 thousandths per cut. Don't know how well you can see that. It doesn't look very clear on my lens here. Alright, I'm just going to turn the mill on. Hit the quill feed. And we'll let it feed down to show you how that gets cut out of there. And it's almost cleaned up now. After I get done with this, I'm finished for tonight. And we'll continue the rest of this sickle mower repair after that. And it looks like that cut's going to clean it up. Okay, now I'm going to reverse it and let it feed up on its own so it'll clean up any excess metal. What that does, it's kind of a finish pass. When you take your first initial cut, your cutter kind of flexes a little bit, and if you let it feed back up on its own, it kind of cleans up whatever it didn't cut, and it gives it a nicer slick finish. Looks like it's got it. Alright, that's all for this video. We'll have to continue the rest of this repair in another video.